Hi everyone, in this video I will be going over matrix decomposition, which is a problem from the 2020 April cook-off. And so the problem statement is that we're given a square matrix M with n rows and n columns. And initially, all of the elements of this matrix are equal to A. The matrix is broken down in n steps, and during those n steps, a certain amount of elements are removed. And the product of all the 2 times I minus 1 elements removed is denoted by P of I. And each of the remaining elements of the matrix are multiplied by P of I. And we want to find the sum P1 plus P2 plus P3 all the way up to Pn. So let's look at the example case. So the input is 1, 3, 2. So we're given a 3 by 3 matrix, and each of the values in the matrix are 2. And so here we can see in the first version of the matrix that the first element that's removed is the element on the upper right. And so in this case, P of 1 would just be 2, because P of I is the product of all the elements that are being removed. And in this case, only 2 is being removed. Then all the elements that have not been removed are multiplied by P of 1. And so all the remaining elements become 4. This brings us to the second version of our matrix, where we have all the elements as 4, and now we're removing these 3 elements. And so in this case, P of 2 would be 4 times 4 times 4, which is 2 to the power of 6. Because again, it's a product of all the elements that are being removed. And then we do the same thing as we did before. We multiply the remaining elements by P of 2. And so then we get this version of the matrix. And so P of 3 would be all these elements that we're now going to remove multiplied together. So it would be 2 to the power of 8 times 2 to the power of 8. And we do this 5 times. And so our total answer would be P1 plus P2 plus P3. And we would mod this by 10 to the power 9 plus 7. Okay, now we need to find a way to calculate each P of I. So we notice that each P of I is essentially the current value in the matrix to the power of 2 times I minus 1. So again, the number of elements we're removing increases by 2 every time, and it's odd. So that's why it's to the power of 2 times I minus 1. And we notice that the base of this exponent is the current value in the matrix, because we keep on multiplying what the current value in the matrix is 2 times I minus 1 times. Now the problem is we need to find a way to determine what the current value in the matrix is. And so we can actually find this by looking at previous P of I values. So we notice that the first value in the matrix is just 2, and that's just A. And we notice that the second value in the matrix is 4, and that would be A times P of 1. And then for the third value in the matrix, which is 256, we notice that that's A times P of 1 times P of 2. So we notice that it keeps on building off. And so by following this pattern and keeping a running product of all the previous P of I's, we can calculate the next current value in the matrix. So now let's go over the code for this problem. Okay, so I'm going to be going over the code for this problem now. And so the first thing I'm going to do is I'm going to create variables for n and a, and I'll input them both in, so cn n and a. And so I'm also going to create variables for the running product, which I'll initialize to 1, and then for the current P of I value, and I'll call that P_val, and then also for the answer, which I'll initialize to 0. And so we're going to iterate through n times. So for n I equals 1, I is less than or equal to n, and I plus plus. And so we know that within this, that the current P of I value would be A times the running product to the power of 2 times I minus 1, because it would be the current value in the matrix to 2 times I minus 1. And so that's A times the running product, as we already determined. So now the issue is that we need to find an efficient way to take the power of something. And so I already wrote the function for this up here. And so let me explain how this works. So the idea is that at each point, we want to try to divide the power by 2. So let's say we have 3 to the power of 10, and we wanted to calculate this value. Then that would be 3 times 3 times 3, and so on 10 times. So the idea is that we can simplify this to being 3 times 3 to the power of 10 divided by 2. So that would be 9 to the power of 5. And so here we keep on dividing the power by 2, and so we keep on simplifying the power. And so that's exactly what this power function does. We keep on multiplying the base, which is a, by itself. So here we multiply 3 by itself to become 9. And then we keep on dividing b, which is the power, by 2. And so by doing this, we get a fast and efficient way to calculate the power of 2 numbers. And so let's use this function, and let's write p-val is equal to power of a times the product, and then 2 times I minus 1. And then we'll take mod of this. And so the next thing we want to do is we want to update answer. So answer is the sum of all of the p of I values. So we would just do ans is equal to ans plus p-val, and then we would mod this. And now we want to update the running product. And so that would just be product is equal to product times the current p-val, and then we would also take mod of this. And so at the end, we can just see out the answer. And so that's how you solve this problem.